Welcome, dear students. This is the fifth module of lesson motion. In this module, we discuss about equations of motion. At the end of this module, you can derive equations of motion by graphical method, and also you can describe the equations for velocity time relation and position time relation. In our last class, we studied about graphical representation of motion in a line graph. You know that the shape of velocity time graph for a car or a vehicle moving with uniform accelerations. In this module, our first topic is equations of motion by graphical method. When an object moves along a straight line with a uniform acceleration, it is possible to relate its velocity, acceleration during motion, and the distance covered by it in a certain time interval by a set of equations known as the equations of motion. There are three such equations. These are v equal to u plus at, s equal to ut plus half at square, and v square minus u square is equal to 2as, or 2as is equal to v square minus u square. Both are same, where u is the initial velocity of the object which moves with uniform acceleration a for time t. V is the final velocity and s is the distance travelled by the object in time t. So, equation 1 describes the velocity time relation, and second represent the position time relation, and the third equation represents the relation between the position and the velocity. Next, we are going to derive the equations of motion from velocity time graph. The first equation is velocity time relation. Consider the velocity time graph of an object that moves under uniform acceleration as shown in the figure. From this figure, we know that the initial velocity of this object is not equal to 0. That means the object is traveling with some velocity. The same graph is given here, but I gave some values for velocity in y-axis for better understanding. From this graph, the initial velocity of this object is 30 meter per second. Length of OA represent this initial velocity, that is u, and also OA is equal to OC because they are parallel lines and same length. Then the final velocity of the object is 85 meter per second from this graph. The length of BC represents the final velocity. So we can take BC is equal to V, the final velocity. So the time interval for this journey is represented by the length of OC, and also it is represented by the letter T as shown in the figure. Also, length of OC equal to AD because they are parallel and equal length. Then, can you find out the change in velocity from this graph? We know that the change in velocity means V minus U. So, what is the representation of V here? It is equal to BC and U is OA. So, we can substitute the value BC minus OA or BC minus CD because OA equal to CD. Then from this graph, this BC minus CD equal to BD. You can observe this in our graph. So, BD is the change in velocity. Consider the velocity time graph of an object that moves under uniform acceleration as shown in the figure. Again, OA equal to initial velocity, BC equal to final velocity, OC equal to time interval, and also BD equal to change in velocity in time interval t, that is represented by V minus U. From the graph, BD equal to BC minus CD. So this is the change in velocity. From the graph, AD parallel to OC. So AD equal to OC because they are same length. Then BD is the change in velocity, that is equal to BC minus CD. From this, BC is equal to BD plus CD. Put equation number 2 here. I already mentioned it. Then from the graph, CD equal to OA because they are also same length. Then rewrite equation 2, we will get BC is equal to BD plus OA. Instead of CD, we can substitute OA there. Then we know that BC is equal to V, the final velocity, and OA is equal to U, the initial velocity. Substitute in equation number 3, we will get V is equal to BD plus U. From this, BD is equal to V minus U, that is the change in velocity. Put equation number 4 here. We know that acceleration is equal to change in velocity by time. So change in velocity means V minus U. Substitute here, A is equal to V minus U by T. Then A is equal to, we know that V minus U is equal to BD. So BD by, the time is AD, or which is equal to BD by OC because AD equal to OC equal to T. Then A is equal to BD by T. Then from this equation, BD is equal to AT, that is substitute the value of BD here, that is V minus U is equal to AT, or V equal to U plus AT. This equation describes the velocity time relation. So what is the equation for velocity time relation? V equal to U plus AT. Next we are going to derive the equation for position time relation. Let us consider that the object has traveled a distance s in time t under uniform acceleration a. The distance travelled by the object is obtained by the area enclosed within OABC under the velocity time graph AB. Here OABC is a trapezium. Thus, the distance s travelled by the object is given by s is equal to area of OABC, which is equal to area of the rectangle OADC plus area of triangle ABD as shown in the figure. So, area of rectangle is OA into OC plus area of triangle is half into AD into BD. Substituting OA equal to U, that is the initial velocity, OC equal to AD equal to T, that time interval, and BD is equal to AT, that is from the velocity time relation. So we can substitute all the values in equation OA into OC plus half into AD into BD. We will get S equal to U into T plus half into T into AT. So which is equal to ut plus half at square. This is the equation for position time relation. Friends, today we derived the equation for velocity time relation and position time relation. Hope you understood this module, and also read your textbook and watch this video carefully. Thank you.